everyone, this video is going to help with parallelograms and proving something is a parallelogram. It's section 14.3 in course 1, maybe a different section in something else, but let's look at the idea of a parallelogram. Most of us know what it is, but we've never looked at the formal definition and then looked at proofs of it and problems with it. So here we go. Theorem 45 is the first thing. If both pairs of opposite sides of the quadrilateral are congruent, then a quadrilateral is a parallelogram. This is probably the most important one of this section. It is what makes it a parallelogram. Okay, so if the opposite sides are parallel, then it is a parallelogram. Okay, and then if we know opposite sides are equal, then we know it's a parallelogram. Okay, the next one, 46, says, okay, if A plus B, so angles right next to each other, are 180, and A plus D, so A and B and A and D are add to 180, they're supplementary, then it's a parallelogram. So there's another one. So if we have opposite sides, then we know that it's a parallelogram. And remember, parallelogram again is opposite sides parallel. This one here, theorem 47, says if opposite angles are congruent, then it's parallelogram. And that is actually if you think about the cut by a transversal and opposite sides, so that one can be proven using those rules of parallelograms with the lines that we looked at earlier in the section. Okay, theorem 47 says, all right, what if we made diagonals on our, let me set that down so it doesn't wiggle. And what if we made diagonals on our parallelogram and we said that they bisect each other? Then parallelogram. Okay, and we had one more, right? I think that was it. Last but not least, through 49, is if you have opposite sides are parallel and you know opposite sides are congruent, it has to be a parallelogram. Okay, so this one's pretty obvious if you think about that the sides would be equal, so then these would have to be equal, and if they're parallel and they're equal. So those are all of the things that we can use to prove something is a parallelogram. So let's walk through a couple example problems. All right. Whoop, whoop. Okay, so what if we said we had something that looked like this, and we said this is G, D, E, F. And we said this one is parallel to this one, and this one is congruent to this one. Can you prove, do you have enough information to prove that this is a parallelogram? So think back to the different rules we had. If we had the same side and they're congruent, and we don't, we have opposite sides congruent and these are parallel, which we don't have a proof of that. So let's see. We also had opposite sides congruent, but we don't know these are congruent. And we had angles. This one has nothing to do with angles, and we don't have anything that we don't have any diagonals, so we don't have enough information to know if these are parallel. So not enough info. We need one more piece of information or two to prove those are parallel. So that's what we're looking at. Okay, look what we're given, and can we use any of those theorems to help prove it? So here is another one that we can prove. What if we have so opposite sides congruent, and we have to label this A, I labeled it land. We want to prove that land, Land, is a parallelogram given that information that we have. So what we want to notice is this is like a transversal right here, right? And if this side is congruent to this side, then we know these two are parallel. Okay, and think of it going this way. If alternate interior this way are parallel or congruent, then we know these two are parallel. So we can say AN is parallel to LD, and we can say that AL is parallel to ND. And y, well, if we thought about the two-column proof, we'd say y over here. We would say alternate interior angles are congruent. I'm running out of room, so I'll just make a symbol there. So because alternate interior angles, we can say these are parallel, because now we've said this is parallel to this, and this one is parallel to this one. We have now proved the definition of a parallelogram. So we can say LAND, land, is a parallelogram. This is the symbol for parallelogram, kind of lame, by the definition of a parallelogram. I love the symbols though, because otherwise you're writing out a lot of things. But so we can use that information before alternate interior angles to prove something's congruent. Which theorem tells you says that if I'm given this information that this is a parallelogram? So you'd have to look through them. So keep your book with you or write them out. Just draw yourself little pictures and write them out so when you do your homework. This one is theorem 47 here that says, okay, whoop, where am I? There we go. Opposite are congruent, then parallelogram. So we can state that this is parallel by theorem 47, or you can say because both pairs of opposite angles are congruent. They may not state like theorem 47 because it might be called that something else in a different textbook. For us, it's theorem 47, and you could list out the reasons. You could also be told something like this is 19x minus 5, and this one's 15x plus 3. What would x have to be in order for this to be a parallelogram? So what do we need to have x be? Well, if it's a parallelogram, these have to be congruent. So we would have to know that 19x minus 5 has to equal 15x plus 3. And then we can just solve that. Well, subtract that 15x over to the 19x. And you get 4x minus 5, bring down the 5, equals plus 3 is just a 3. Now add your 5 over, and you're going to get 4x equals 8. Divide by 4, and you're going to get x is 2. So you can find missing sides because we know they have to be congruent. And that's pretty much all they do, is basically make you use those theorems to prove or not prove if you have enough information or not. And they might throw a couple equation solving problems at you. Hopefully this video will be helpful.